we have 3 cosine of theta, which is our circle, and then we have our cardioid, which is 1 plus cosine of theta. And then so we're going to set 1 plus cosine of theta equal to 3 cosine of theta. So we get 2 cosine of theta equals 1, and then we get theta equals inverse cosine of 1/2, which equals
Pi over 3.
pi over 3. So this point right here is pi over 3.
Can you
Cool.
Can you draw a line to the origin so that you kind of know which angle you're talking about?
From here to here?
Yeah. So that angle is pi over 3.
That angle is pi over 3. Okay, thank you.
Alright. So now that we have this angle that you found, that's actually where we're going to start our first integral off. As you can see, we want this, all of this area here, since we want the area outside the circle but inside the cardioid, you want this here. And since that's divided up into 2 integrals, because this half is in the first quadrant, it's bounded by both the outside cardioid and the inside circle. However, once you move on to the second quadrant, it only has your cardioid in that quadrant. There's no longer a circle in there, so we're going to have to set up 2 integrals for that. The first integral is going to be bounded from our lower bound being our circle to our upper bound being the cardioid. So it's going to look something like...
Go to the corner.
Here, try to go up here so we see real estate.
I see.
There you go.
Okay.
It'll be from 3 cosine theta to 1 plus cosine theta. That'll be our first integral, since that's coming from our circle here off to our cardioid, which our circle is the 3 cosine theta function, and the cardioid is the 1 plus cosine theta. As for expanding it, we're going to go from pi is equal to, or rather, theta is equal to pi over 3 to pi over 2, because we're only grabbing this part here since it's bounded by both the circle and the cardioid for that area. And that's the area we're grabbing first. That's going to go from our intersection point, pi over 3, to pi over 2. Take that off. And that's coming from this area here that Jeff outlined. And that's our first integral. You want to go to the second one?
No, you can do it. Our second integral, let's just put it right here.
Alright.
Go ahead. Since you're
Alright.
there.
Our second integral is coming off from where we left off, up to the end part here. So we're only going to be grabbing this area first, just because we know that this is symmetrical. This cardioid is right on the origin, along with the circle. So since they're symmetrical and we know they're on the origin, we can just grab this half first, and then we can multiply it by 2. So that's exactly what we're going to be doing here first. We already got this area here, and so now we need to grab this second quadrant. And that comes from being bounded by 0 up to 1 plus cosine theta. And the reason is because that cardioid that was in our lower bound from before is no longer in the picture in the second quadrant. So we only really need
The circle is not in the picture.
or rather the circle is really not in our second quadrant. So we really only need the cardioid and our radius coming from our origin, since there's nothing else other than the cardioid in the second quadrant.
Very nice.
So now we can expand that off from theta is equal to where we left off, remember, over here? That's pi over 2 to so we left off from pi over 2 off to pi.
Nice.
And then we can just fill in the rest. That's our first integral is our radius one, and then our second one is our theta.
And then on top of that, we need to times each integral by 2.
Why do we need to multiply by 2 as you both said?
Because we're only looking at this